Okay, so this lesson is going to focus on the hominin ancestors. So by the end of these couple of screencasts, you should be able to name the key genera in the hominin line and recall their significance or the importance of why we remember them in the timeline of hominin evolution. Okay, so this slideshow corresponds with the, let me just get out and show you, exit worksheet. Should look like this, hominin species chart. So as you go through the screencast or the slides afterwards, if you just want to watch the screencast all in one, your task is to complete this worksheet here, and I'm going to want to see evidence of this. So I would appreciate if you could complete it here on Google Docs, but if you want to put it in your book as well, that would be really useful to manually write it down so that it sticks in your head. Alright, so my first thinking point for you, usually we'd do a think, pair, share in class, but it's going to be, I want you to think about which pair of species below you think are more closely related. So first combo is Homo sapiens with an S and Homo heidelbergensis. And the second one is Homo neanderthalensis and Australopithecus afarensis. So I'm not going to wait, but you can have a pause and a think and come back when you are ready to justify your answer in your head. Okay, so the answer is combo number one, Homo sapiens and Homo heidelbergensis. And the reason for this is quite simple. When we name species, we put them in what we call a taxonomic rank. And we have a number of ranks that basically narrow down, what would you call it? The clade of that species into smaller and smaller groups. And the smallest group that you can be a part of is a species. Okay, and the next smallest group is a genus. So a genus will include a number of species that are closely related biologically, and that's represented in the genus name. So Homo sapiens, Homo heidelbergensis, Homo neanderthalensis, Homo erectus, all of those beginning with the word Homo, that's the genus name, and that indicates to you that they are closely biologically related. Okay, as soon as you get a different first word in the species name, that is representative of that species belonging to a different genus. They may be within the same family, so still more closely related to you or to a certain species than something from another family, for example. So the bigger the group, the more things included. So the phylum, for example, we are part of the phylum Chordata, and that includes all species that at one point had kind of a primitive version of a spinal cord. And within that you've got class. So our class is mammals, and that includes lots of mammals from all orders of life, such as primates, or you've got carnivora, for example. That would be like tigers and bears and things. So they're another order within the same class, same phylum, same kingdom, being Animalia. Yep, but that's where our similarity with tigers end. And then within that, our family is the great apes, our genus is Homo, and our species is Sapiens. So hopefully that makes a bit of sense and you've seen something like that before. Next, think, pair, share. At which bifurcation of this hominid tree does the hominin line begin? So have a pause, have a think. And the answer is fork D. So we know that hominins include any species that is more closely related to Homo sapiens than it is to a chimpanzee. So the only hominin that is extant today is us, the Homo sapiens, but we had many ancestors in the hominin line that were more closely related to us than chimpanzees. So even Ardipithecus ramidus, yes, looks very much like a chimpanzee, however, evolved more recently in the timeline than the last common ancestor that we had and our line had with a chimpanzee. So still, according to this graph, Homo sapiens and chimpanzees came from a most recent common ancestor around 5 million years ago. But if we say that Ardipithecus ramidus is on this fork here, well, the last common ancestor that Ardipithecus had with human or modern humans, Homo sapiens, is about 4.9 million years ago. But Ardipithecus and chimpanzee, 5 million years ago. Yeah, so everything along this line after this point has had less time, less evolutionary time to accumulate mutations in DNA that separate them from us than they have from a chimpanzee. And that reflects how different we are biologically, and by the same token, how similar we are. Okay, we should remember that by now. We did go over that a few times in class. How many genera, this is the plural of genus, so the first word in a species name, do you see in the hominin line? So again, have a pause, have a think, and the answer is 4. So if we look at the first word, we've got this branch of Ardipithecus. Now there is more than one species. This is a simplified version of a cladogram here. So Ardipithecus genus, we've got the Australopithecus genus, Paranthropus genus, which is sometimes included in Australopithecus. Some people include them as one, some people say that they're different. And then the Homo genus up here. So these genera actually include many more species than are represented here, but these are just some of the most significant species that we might focus on later. So again, these are all just different ways of representing the relationship between different species. So here on this timeline, we've got all of those species again and more. The length of these lines represents how long in the timeline that species existed for. And yeah, you can see heaps of different ones, how they're related. Again, many of these are different. These are all examples of how people have put together trees based on evidence, but there's a lot of contradiction. So this whole tree here of hominins would fit onto this tree just along this branch here. So after the separation of this hominin line from the last common ancestor that we shared with chimpanzee. So yeah, this is our hominin line here. These are all considered hominids, so the great apes, extant and extinct. So along these lines would be many extinct ancestors of gorillas, chimpanzees, bonobos, etc. And they are all considered hominids, but not hominins. So now that we have an understanding of how our ancestors are named and ordered, which is important, we're going to start from the beginning, looking at our hominin ancestors and move upwards through the timeline. And you can go back and forward between this and the Google Doc and just fill in what's really significant about each species. Sahelanthropus chilensis is our one of our very first ancestors that emerged after the divergence from a common ancestor with chimpanzee. Chilensis was found in Chad, which is in Central Africa, and only skull fossils were found. Now, Chilensis isn't a species that you need to recognize and remember anything significant about, but I included him and a few others as examples of the fact that we will be looking closely at a few, but we need to understand that there are so many species in our hominin ancestry that we won't be covering, and Chilensis is one of them. So you won't see him come up in exams unless the information is given, but yeah, there are heaps of them species out there that we won't be covering in detail, but they're still important and kind of funky. Alright, so Ardipithecus, or Ardi, lived about 4.5 to 6 million years ago in Ethiopia. Spelling error, sorry. So what Ardi had in common with humans was a forward-facing front toe that was robust enough to indicate he may have toed off. So like we said, heel, strike, toe. Push is the kind of mechanism we use for walking on 2 feet. Another piece of evidence towards being bipedal is the fact that Ardi's foramen magnum was relatively basal, so underneath the skull. So we assume that he walked on 2 legs at least some of the time. Australopithecus afarensis and africanus. So Lucy is a skeleton that we talked about recently, and that was a 40% complete skeleton found in Ethiopia. Lucy lived about 4 million years ago and was very short. So if you want to go back and have a look at some of those videos of Lucy walking, I think that was in the locomotion slideshow. Lucy had a small brain, around the size of a chimpanzee, so about 400 cubic centimeters, but was evidently bipedal, and that's really important. We can see bipedalism in the fossil record, reflective in her basal foramen magnum, broad pelvis for holding the legs at an angle that gave it that valgus support. And there are archaeological evidence, there is archaeological evidence found as well. So this is Lucy here. This is her pelvis compared to a chimpanzee that is on 4 legs. Okay, here's an example of how she has a foramen magnum and more robust joints for walking on 2 legs, whereas a chimpanzee does not have the valgus angle that goes in towards the center line of the body, so he has to move his body the whole way over to balance on 1 foot if he wants to walk on 2 legs anywhere, so it takes a lot of energy. So here we've got Lucy on the right compared to a chimpanzee on the left, so you can see actually if you look closely at the skeleton some really big differences, although on the outside they look quite similar, and then human in the background. Okay, these are the footprints of Laetoli. So this is in Tanzania around Lake Victoria, and Australopithecus footprints were preserved in volcanic ash, so they walked along volcanic dust basically, which settled and hardened, providing fossil evidence of bipedalism millions of years ago, which is really cool. So this evidence reinforces the idea that bipedalism preceded larger brains. So she had a small brain, but she walked on 2 legs. And remember, we keep coming back to that soundbite. Bipedalism was the driving force of evolution. So bipedalism came first. That provided us with our hands free to do things, to confer a selective advantage, which allowed us to survive and grow our brains as we were able to procure more, nutrient-dense foods, blah, 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 blah. And we'll keep reinforcing these theories as we go. Australopithecus genus contains around 10 species. So we learnt about Afarensis and, what's the other one? Africanus. But there are so many more. So these species were known as gracile australopiths. And we're going to talk a little bit about robust australopiths in a second. Not essential to understand, but remember I did talk about how Paranthropus genus was sometimes considered australopith as well. So this is the Paranthropus genus. As you can see, he's got a very robust skeleton and skull. And when these 2 genus were considered one, Paranthropus was the robust version of Lucy, basically. So you can see prominent sagittal crest, thick mandibles, and they had massive molars. So these species were adapted for a very specific diet, which mostly probably consisted of like grasses and really fibrous green material. Although they've been nicknamed Nutcracker Man, as originally scientists thought that they ate really hard seeds and nuts and things like that. So this is Paranthropus dental arcade here. Look at those molars. They're approximately 4 times the size of our molars today. So just massive. Okay, so quiz, true or false? Paranthropus are hominids. Paranthropus are hominins. Paranthropus and Homo have a common ancestor in the hominin line. Paranthropus are direct ancestors of modern humans. All right. Pause there if you want to have a think about them. It is worth it to test yourself. And now I'm going to go through the answers. So Paranthropus are hominids. This is true. Hominids include all of the extant and extinct great apes, and that includes this line plus chimpanzees, bonobos, gorillas, orangutans, and all of their ancestors as well. So yes, true. Paranthropus are hominins. Correct. The hominins include everything along this line here that has arisen as a result of the divergence between chimpanzees and the hominin line. So true. Paranthropus and Homo have a common ancestor in the hominin line. So if we work backwards from the Paranthropus genus and the Homo genus, our most recent common ancestor is here. Okay, the last time that our lines were connected. And yes, this ancestor here is a hominin itself. Okay, so it's along this line here. So yes, true. Another common ancestor we have is here, another one